Would you believe me if I told you that e, the natural number associated with compound interest, pi, the ratio of the circumference of a circle to the diameter of a circle, and I, the imaginary square root of -1, are related? Well, I wouldn't believe me either, but that didn't stop Euler, one of the most famous mathematicians of his time. Leonard Euler.
I believe that says Euler?
Yes, it is actually pronounced Euler. Aside from his name, Euler derived one of the most famously beautiful math equations to date called Euler's identity. Now, how on earth did Euler get such crazy numbers to align with each other? In order to understand that, we first need to understand Taylor series. A Taylor series is simply another way to represent a function as a sum of an infinite amount of terms. A special kind of Taylor series, called a Maclaurin series, can be represented by the following equation. This equation includes infinite arithmetic sums, varying order derivatives, not even to mention factorials.
What?
A Taylor series can be boiled down to a very simple concept. These series are just like a puzzle. First, this formula can be broken into smaller parts. The Greek letter sigma means that we add all of these terms from the starting point to the end point. When we add these terms up, we get closer and closer to the real function, just like as we add more puzzle pieces, we reach the whole image. So how did Taylor series help Euler? He needed 3 special series, the one for sine of x, cosine of x, and e to the x. Now, Euler noticed that these series look really similar. It was almost as if he could add 2 of them and get the third, but something was missing. He needed a way to make certain parts negative and certain parts positive. That missing thing was the imaginary number I. I is the square root of -1. Because of this, if you multiply by I, you get that I squared is equal to -1. If you multiply by I again, you get I to the third is equal to -I. And lastly, if you do this one more time, you get that I to the fourth is equal to 1. As you use higher and higher whole number exponents with I, the result will be one of these 4 values. When Euler included I in the series for e to the x, he could reorganize the terms to look like the series for cosine and sine multiplied by I. This led him to create his famous formula.
Amazing, right?
But the fun doesn't end there. What happens when we set x equal to pi? When we plug pi in for x, we get the beautiful identity that e to the I pi is equal to -1. These 2 identities simplified many facets of math and science, including electrical engineering, alternating currents, and quantum mechanics. With this, Euler successfully combined the complex number system with trigonometry, which goes to show that even 2 completely different things can be unified to make one beautiful concept.